Okay, this is Collin Software's Jane page. We're going to look at flow control. These are some examples I've programmed. Janic is a language of Jane, which is an emulation of JavaScript with some extensions. And one of those extensions is flow control. So we'll look at the first example here, which is a simple, this is the main routine. So I want to call A, function A, immediately calls B, but says wait for it. Means that B is going to be an asynchronous function. We call B, we get an alert there, and then we set a timeout to call C for 2 seconds. So actually B is going to exit, wait 2 seconds, and then we call C. So C is a subfunction of B, but it's an event, so it will satisfy the function B. C will then come in and do an alert and return 100. Now it's not returning C is an event of B. B is going to return to A up here. A equals B. A will have the value of 100. We'll alert that, and finally we'll get down and done. So what we're seeing here is a whole lot of flow control. So if we run this, here we get that first message here. We wait 2 seconds, we get this alert C, this finally gets done, and then we come up here and we return done. This is how we control the flow asynchronously. Parallel operations, I want to run a parallel operation of, and I'll run and read those asynchronously and wait for all 5 to get done, join them together, and return those values back to here. So when we run this, it doesn't take very long, but basically it sent out 5 requests simultaneously or as fast as I could, got them back, and then these are the files of B. If I say 6 does not exist, so file 6 is not found, 404. So it went out to the server said it doesn't exist, and so that just proves that what we're running is 6 parallel operations. Okay, so if we look at this, these are read files in parallel. This is an extension of my language which says if I have proper case names, that's actually one variable. So this is one variable, read files in parallel. I just did this to show that we don't need to have camel case or anything else. So read file is another proper case name, so we read files in parallel. I pass minimum, maximum, come down here. I set all my files to be a blank array. I set my file name to the file that I want to read. I initialize my file by index, which starts at 0, and then indexes. And then I read, and I continue, says read the file, but continue, program execution, don't wait for it. Pass it the file names. This is a little strange, but this is passing a value by reference so that this value can be filled in from external references. And then here I wait for events 5 seconds until they're done. Either wait here, if they're not done for 5 seconds, then go ahead and exit and cancel all the operations. And then the read is, here's a read file, here's my standard XML HTTP request, and on load is an event, and so this is going to satisfy that particular wait, and it's going to return to the file my result here, which is this result, which is this file passed by reference. Two-way communication. We'll look at two-way communication. Call A with a value, A calls B with that value, B says if that value is less than 4, which it is, then it will re-enter the calling routine at not found, so it'll re-enter here. This is actually just the same function, and pass it n times 2, which is 6. Comes down here with 6, it prints k, and it resumes this n value here. It resumes and passes this n value back at 6 times 10. It's some calculation. So when we run this, k equals 6, it came here, and then done 60. So if I pass 4, it gets 4. So what we're doing is we're allowing the parent routine to determine the action of failure, which we, instead of B taking care of it, it just simply says, I don't know what to do. So he calls the parent. Parent does know what it's doing or not, and it can pass it back. Anyway, this is better flow control between two functions that are actually in storage and can talk to each other. Here's a refresh screen. Here's do something, which is again my proper case thing. I want to make a progress bar. This is just standard HTML stuff to build a looks like standard JavaScript, but this is actually in Jane. Okay, and it's going to set the thing. It's going to wait 15 milliseconds, slow it down, and then run the progress bar. So when I run this, and it says canceled, so this is window.canceled, if I could put window.canceled. So here on this click button, I can have a cancel button and cancel it. So when I run this, it runs and I can cancel it and done. So it's actually doing something and waiting. So this is basically can be down at any level within the program. It could be 100 levels down in a program, and it will return and then return to the calling routine. Okay, so we'll run that again. If we want to slow it down, we can slow it down even more, and that's just, this wait is just simply, it's actually a refresh. I could put refresh, which I did down here, but it doesn't wait. I did a wait to wait a certain amount of time, and so now it slows it down. And this allows me to put in a progress bar or communication to other devices simply by putting in a refresh, which is to get out of the program, go see if there's any other actions to be done by the DOM model, and then come back and continue execution. Okay. Exception handling recovery. This is my 5th example here. I call A, and I try and I catch it. Okay. Basically calls B. B says, I just wanted to go down a couple levels, just show you that it's going all the way back up here. Fruit counts of name, which is pairs, is 30. If it's not, then it's going to throw name. So it's going to come back up here, and it's going to have name here. And it's going to allow you to either continue execution or to cancel the operation. So when I run this, it says, we have no apples, would you like some pears? So it's here, we have no name, apples, would you like some pears? If you say okay, it will resume and it will order your pears. If we run this again, we have no apples, would you like some pears? You can say cancel, your order has been canceled. Again, this is to communicate to somebody that I have a condition that can't be met, you handle it, and if you want to, we can continue from there and return values. So that is exception handling recovery, so I can recover. Okay. And then here is a simple wait in. I start waiting for 10 seconds, and then I return, and then I do my alert. So this is going to run, and it's going to start waiting 10 seconds, and during that time you can do whatever you want, go someplace else, and it's going to come back in 10 seconds, done 10 seconds, and so these are the basically flow control of asynchronous communication, parallel execution, event recovery, exception recovery, communication between functions, and finally doing your progress bar kind of operation. All right, thank you.